we're going to start at the moon in order to recount the history of science. Yesterday, we began a special series. Today is the second presentation. I want to show you where we left off yesterday. Don't worry if you did not see that 2-hour lecture. Since we are now talking about a spherical orientation, a knife edge you could think of as the straight line, but the Fermi edge is a bubble. And that's our heliosphere is a bubble in intragalactic inside of a galaxy. What we normally say in that situation, interstellar space. And for you science fiction buffs, you may get a little goosebumps on your arm. Interstellar, ha ha ha. That movie, by the way, is crap. Okay. Interstellar, if you haven't seen it, don't. It has been analyzed by some cosmologists who are quite unhappy with the portrait of the black hole, although the population that watched Interstellar loved it. My family came to me saying that they finally had something they could share with me, since none of them care about astronomy or really science at all. What we're trying to do is get out here. We did that yesterday. These are interacting bar spiral galaxies. We're going to start where we all start, as I am seeking to summarize the information that I have put together to give us understanding as laymen for what's actually been discovered. How much do you know about it? Well, I can tell you this, we're all beginners here. Remember this, that the experts do not any better understand the universe than you do. The only way you can understand the universe so that it actually matters, that is, it makes sense realistically, is if it changes your life, if it changes you. Why do we do science? Today, when you first looked at this, you experienced a sense of wonder. You may have seen something like this and experienced that wonder again. We're going to relearn geometry the easy way, the way it could have been taught to us in school. Geometry was not taught to us the way I'm going to teach it to you now, for the purpose of understanding, which is the goal. Although there's always a goal beyond the goal, that has to do with wisdom, and that pertains to you alone. What Fritz is talking about in the discrepancy between men's plans and the results achieved, men's plans are what I was just talking about, what humans want, and the results achieved, how has science contributed to the human equation, either for an individual or for humanity as a whole. It's not calculus. It's not models, it's not theories, it's not complexity and complication. It's what we actually know. That's what a layman wants. Okay. To eliminate the discrepancy between men's plans and the results achieved, a new approach is necessary. Morphological thinking suggests, that is, geometric thinking suggests that this new approach cannot be realized through increased teaching of specialized knowledge. For that, read calculus. So the increased teaching of calculus is ineffective to break the logjam. We don't need more mathematics. Mathematics has failed to a threshold. It hasn't ultimately failed because calculus produces technology. That is what it's for. But because it's so successful, it's also being used. Remember that you were taught geometry. Now, geometry is for visualization. Oh, I will show you the relationship between the two, which is not ever taught. The specific relationship between mathematics and geometry, in the opinion, obviously, of Fritz Zwicky, geometry takes precedence. And here's how Fritz phrases that. Morphological thinking, that is geometric, suggests that the new approach cannot be realized through increased calculus, through increased mathematical tools, through the increased teaching of specialized knowledge. That's what Fritz is talking about. And now to finish the quote, this geometric analysis, the proper term is morphological, and I'll be teaching you what that word means. It basically means geometrical. This morphological analysis suggests that the essential fact has been overlooked, that every human is potentially a genius. That's an amazing statement, and Fritz is not alone in thinking that. I totally side with that point of view. You are potentially a genius. That's what Fritz is saying. Every human is potentially a genius. You could actually take that further, but it's well enough said. Education and dissemination of knowledge must assume a form, that's the form we assume, geometry, which allows each student to absorb whatever develops his own genius, lest he become frustrated. Let me put that positively. Every student is given the freedom to develop his own genius because the form of the teaching encourages that. The student will become a scientist, which is good for all of us. We need more scientists who think rationally and are capable of becoming solution-oriented humans. There are two ways of going where no man has gone before, okay? And one of them is psychotic. And it's far easier to go that way. When you're trying to say what the universe is, you have to be sure of yourself in science. You say every single time that you're guessing that it's a theory. You're allowed to do that. But you must say it's a theory. That rule is no longer followed. It's a break with reality. We don't like to hear theories stated as facts. That always upsets a scientist. Not anymore. My job is to make sure that you understand what science knows so that you can use it. The same outlook applies to the genius of the peoples as a whole. What Fritz is saying is that as you enable the individual, you enable science itself. I believe that that's self-evident. My theory is unknown, so it has to be called a theory. I just said so, because it hasn't been proved. Now, I have proved this new geometry to myself. Well, anybody can fall into that trap. No, that's why we have consensuality. It's to safeguard the scientific process so that you don't sneak something in. Misleading theories have entered into science at the cosmological level, and I've documented that well enough in the 300 lectures that I've already produced. It's going to go against the current paradigm, so you have to be cautious. With me, as well as anybody else. I can say all the things that they say. I could be trying to fleece you, deceive you. I don't think these men are evil, okay? And we're going to leave it at that. Because that's what the religious prophets have all told us to do about that. If you see what you think is evil, hold off. Don't ever jump at the gun. Because evil is everywhere in many forms. And what you see as evil, you might be misperceiving what you see. And so the advice given by Yeshua, the Buddha, and even the Prophet, but they all three say the same thing. Islam, Buddhism, and Judaism all have the same advice from the source, okay, as they see it. Try not to point the finger, especially going ad hominem, you jerk. I'm very careful always to say that I'm not impugning the man, but when I use the man's name, and I'm using him as an example of what not to do and why not, that can easily be, it's not even misconstrued. It could easily be taken to the heart, like You saying that about me? Why, you, and now you have a fight. To whatever degree, I mean, this is how wars start. And the war between Leibniz and Newton is just one more example of a petty war that in science is never appropriate. And I have got to confess, I don't really see any way out of it. You're going to step in it. The more serious you get, the more you're going to find out there is another serious party. For instance, I'll give you an example from when I was growing up in the 1960s. I know, but I am that old, yes. I was just entering high school. I entered high school in 1968. So you do the math. Well, I'm 68 years old, so there. And so, what I got involved in right away, right out the gate, the first scientific interest I ever showed, other than for like jets, but not really as a scientist, I just like jets. And rockets. And explosions, all of which you get in cosmology, don't worry. I got my fill now, Daddy-o. But when I was 16 years old, 15 years old, I was taught in biology what we all were taught about biology. And biology, there's lots of things to learn about cells and mitochondria, and we're taught about DNA, but of course, I mean, this is like 50 years after this, less than 50 years after the Scopes trial, which tried in the United States court, I believe, in Tennessee, whether or not it was okay to teach the theory of natural selection in schools. And then the whole thing just blew up into a debate between creationists, which basically is Christians in America. But it's not just Christians, but that's how it got labeled. And was I a Christian? Not at that time. My family is atheist. And so at the time I was not a Christian. I didn't know anything about God. I had never thought about God. I guess you could say I was an agnostic, an existential agnostic. This is important. I do need to say this. You will benefit from what I'm saying, so put up with my little story. And then I swear, we'll talk about this. Now, yesterday we talked about the cosmic units. Oh, mamma mia, you should watch that video. But I'll cover it again today because I promised to show pictures, especially of the quasars. But to finish my story about natural selection, of course that's what we were taught. But at a time when the Christians were going out of their minds, because what they were saying is that natural selection really isn't very good for the kids. Now, I disagree with that, but the issues really went deep. I think most rational people would have to scratch your head about it, particularly, if you are a religious person. It's like, what are they saying? What are they saying? Well, dear, you're just talking to your wife or something, you're discussing this with the boys. What do you think we should do about this goddamn natural selection bullshit? And we're talking about it. How should we vote? How should we react? Put pressure on the school. Which way? How do we think about natural selection? Well, I think most people today, and I would count myself as one of them, would say, well, it's a theory, and so you should teach it if it's a theory. I don't see any harm in teaching a theory. We teach the Keplerian theory, but we don't believe it. We're not teaching it like, well, you had better believe this now. Kepler says, or not Kepler, he's before Tycho, before Kepler. That guy goes way, the guy who wrote the Almagest. He's the guy who had epicycles. Because the planets going around the sun, they weren't sure that planets really were going around the sun, because it looks like everything goes around the Earth. And so people were still scratching, this is about 1,000 years ago, how does everything go around the Earth? The guy who wrote the Almagest. The guy who had the epicycles. So I'm entering high school, and I'm taught natural selection, and I'll tell you the truth. From the very first time they showed me the pictures of the monkeys, it just shows you the amoebas are down here, just one-celled organisms. And then it shows diatoms, they're more complex. They got, then the radiolarians, these are all one-celled, it just goes up and up. This is how life began, with one cell that's just obvious, like they're doing a mathematical sequence. What the fuck do I know? And so, okay, I'm listening, but... And you get up to amphibians, and they just look you right in the eye. I had, teachers just year after year say this. They just look you right in the eye and just absolutely dead serious. And then they turned into amphibians. And I'm like, that's millions. I knew, even as a kid, I think a lot of us did, you went from one cell to millions? I say, well, evolution. Well, no, you have to know. And we're like, or I wasn't alone, but there are a few, we talked about this, like, what do you think about that, We're like, we're dubious, man, right from the go. Well, nobody is now, so this is different, so you should know about this. And then, you know how it goes. There's amphibians, okay? They have special kinds of lungs, but you see, they had been fish. So it really goes from amoebas to radiolarians to like algae, which is more complicated. They evolved and discovered light. And I'm going, God, it took us thousands of years, so I guess it could take millions of years for the bacteria to discover. But they did. They started using it. Photosynthesis. I'm going, those are some goddamned clever fucking bacteria. I'm thinking, I've never seen a bacteria that looked to me like it could think. It just makes you sick, gets in your throat. They have to give you penicillin, you don't like it, you're sick, you have to get a shot. Bacteria, they don't seem like they would be looking for light, okay? It's more like they're looking for death. But this is just, a kid, I'm just 14, 15, they tell me year after year, just showing us it's up on the walls, dinosaurs everywhere. Dinosaurs were huge because of this controversy going on that we kids really didn't know about. I didn't. In the Christian families I found out later in high school, they did know. That goes against what God says. And they're like thumping on the Bible, and I learned about this later, but I did not know it at the time. It's like, sola scriptura, this is amoebas, there's algae, and then there's fish. And they have millions of cells, they have a digestive system, a nervous system, they have a skeletal system. How did the germs think this up? It's not clear how they thought this up, but they did, and they say every time, like a litany, evolution. Then they stare at you. Do you understand? And they test you on it. Like it's on quizzes. It's like, so what's after dinosaurs? And then you have to know. It's like, well, mammoths. That's correct. After dinosaurs came mammoths, whales, which even the author of Moby Dick, whose name I'm not even going to try to remember, He had a difficult time. He spent pages talking about whether the whale was a fish. Because the Bible says, so you learn things when you don't know anything. It just comes in these rumors and strange terms. It's like, I already knew because they had taught me through biological evolution, I guess, that a whale is a mammal. But actually, really. And so they had a theory, well, it was a mammal, but it went back. It went back into the sea. And they look you right in the eye and then they test you on it. So how come whales are mammals? And you'd better know. It's because they had been mammoths. And the mammoths went back and became whales. The mammoths came from the dinosaurs, which are now gone, which needs to be explained. They couldn't explain it. The only explanation that anybody had for why the dinosaurs were gone was in the Bible. And I didn't know that. I did, but I wasn't judging anything. But you have to. Because now they're going to test you on it. Is the Bible true or not? And you have to say no, or they flunk you and then you starve to death. So you have to know the right answer, and they taught you, so you'd better know, is the Bible true or not? And you have to say no. And they're watching you as you say no. I saw a couple of guys just staring over my shoulder and then backing away when I looked at them. And they had badges and they wore shiny black shoes because I wasn't responding right. That in the past I would just write, yes, the Bible is true, because you don't know. I just write it in and write in my answer, which is you don't even know what you're talking about. So why are you asking me about this? They didn't like that. But I learned, by your senior year, and I did learn. Natural selection says, no, there is no God, therefore no Jesus, no Buddha, there's no hope, and love you learned like a bacteria. And I'm like, that sounds correct. That actually sounds correct. But I didn't know. And the final question is, are you willing to sell your soul to the devil right now for money? Yes or no? And then below that is a question about, if not, which branch of the service would you like to die in overseas? You're probably not going to be an Air Force pilot so you're going into the Army and going to Vietnam. Just like the other, some letter of the alphabet word people. So are you willing to sell your soul right now for money? Or would you like to go into religion? So I chose religion and said, fuck the scientists. I hate you all. You do calculus. You're of the devil. You lie, you cheat, you make bombs, you make bullets. You're going to the moon. I hope you don't get there. I hated the Pentagon by then. It just got worse. It's like you're all scientists. Well, you're the ones who destroyed the Japanese people. As a military mind, I knew why we had it. And of course, actually, I approved of it, just like everyone else did. But I'm ashamed of it now. Just like Feynman, just like Einstein. You gotta finally face yourself in the mirror. You fucking killed the Jews, man. I was rooting for Hitler before, pretending I don't know the outcome. I'm fucking betting on Hitler. Seemed like a nice guy. For Germany, it was a hard time. But then, I just really wasn't clear about I kept hearing about the Jews. And I did not know what that meant. So it was a real long time before I even was interested in science. I never did astronomy, except under the influence of psychedelics. And then it was great. I loved astronomy, but I've never got a telescope because of calculus, or mathematics, or using a screwdriver. Fuck you all. Work for the government, you're industrial slaves. And so I'm supposed to assign my soul over to you. So I went into the Navy. Because it's a stepladder sequence down. Oh, really? It starts out, you're not going to Stanford. No. But I wanted to yeah, of course, it's the nearest university. I used to ride my bike there. I used to ride to Stanford because I wanted to be there so bad. I just basically hung out there. Eventually got into their stacks, learned some shit in their library, so I got a pass. But I didn't make it. Yeah, junior college. Well, that's the same thing as technical school. You just weren't smart enough to get into the aristocracy. You're gonna have to, yeah, there's the shovel. There's more steps going down. How far down do you want to go? Yeah, well, you're not going to Stanford. And I'm like, okay, well, you shoot high. It's American. It's okay, but you're not going to Stanford. What about the Ivy League colleges? There's like a couple of dozen Ivy League, Cambridge, Oxford. It's like, no, no, no. Grades, no. Attitude, no. Credentials, desire, no, no. He just wants to be where there's brick and ivy anywhere. And so, no, that's not enough. He didn't sign over his soul. They know. He never really learned. He doesn't think he's from a monkey. He refuses to answer. He doesn't think that bacteria can become so good that they learn how to make light into energy with their little tiny algae bodies. And then they made rhinoceroses and giraffes and barking seals and then humans. Really? Oh yeah, that makes sense. You explained it all. What's the mechanism again? Oh! Millions of years. I didn't need to know mathematics to know that was a fucking lie, okay? That's a lie. That's a cop-out. Millions of years and that's your mechanism. Ha 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 ha. You dirty swine. But I wasn't sure what to do next. So I stayed away from science, Daddy-o. Until I was in my 50s. I mean, unless you count be a scriptural scholar, a Bible expert who learns Greek just enough to be able to read a lexicon and then learns Hebrew just so he can figure out the tetragrammaton. What? That's not science. Actually, it is, but it's not a precise science. Hug sound. That's good luck. If I make the hug sound laughing, we've learned that that's good luck in our astrology class. Kepler was in it, so I attended, yeah. You can learn a lot from the I Ching, which I know how to pronounce in Chinese. My dad would say to us kids, he said this more than once because he thought it was such a good joke. We didn't care. He could still make you laugh the second time. I can speak any language, kids. And we're like, Daddy, whoa, hold on. That's what that stare means. Because we don't know. He's our daddy. Maybe he does. Sounds preposterous. We talked about it later. You weren't. No, I never. I wasn't sure about. None of us saw the joke, though, coming. He said, I speak every language except Greek. And of course, you know what happened. It's like just out of a comedy skit that we really just read our lines. I think I was the first. Oh no, it was Lori. Well, all three of us. Chinese, speak Chinese, Daddy. And I'm like, speak Swahili, Daddy. And Kim's like, speak, whatever she came up with, French. And he stared at us and we're all like, and he says, it's all Greek to me. And my mother laughed from the kitchen. And so we knew it was a joke. And that's how I learned what a joke is. But that's not really cosmology. That's where we begin today. It's that thing. Now what that is, Arp. Dr. Halton Arp. Here's a little better picture of him when he was a younger man. So I have a very strange background in how I got into science. At first I hated it, did not trust it. They seemed to be liars. We're from monkeys. I went with the Jesus people on this. That was the level of my anger. We're going to go to a very special observatory right now. I've taken you to our observatory for a different purpose. And you paid for your ticket, so now you get to take the ride, as Hunter S. Thompson put it. So here we go. We are now on the dark side of the moon. We'll just say we're on the moon to make it safe. We're not in a bubble. The way we're going to approach that now is a specific sequence that's called an algorithm that I developed expressly to teach a theorem, which has a name, but you won't find it in Wikipedia. This theorem is called the antipodal theorem. And in order to execute this theorem so that you will understand it, we now need to turn off all the lights in the sky at our observatory. On the dark side of the moon, the stars just all went out. And now the moon is gone. And you and I are no longer two. Only one of us is there. We're going to give that a name. We're going to call it a point of consciousness. And that's all we're ever going to say about it, because it never really matters. But we're starting over, and that's the right way to start. It is a relativistic beginning because I made a distinction in the empty space we just created to begin our geometry lesson. There is one thing. That is called an RF, a frame of reference. It's abbreviated RF, two capitals, RF together. Reference frame is a point. That's the only time we're ever going to refer to the geometrical object called a point. That a point only represents one thing in the whole universe. We're saying so, but it actually won't matter. But I'm adding it because it might matter. And since it's true, we might be discovering something new. So I'm going to assert axiomatically that the only point in space that we're in now, which is empty space, where we used to be on the dark side of the moon, but now the stars and the moon and everything else are gone. And what's left is a point called a point consciousness. You could say a consciousness point. Either way is fine. But that's the only definition of a point that we're ever going to have. And hold that thought in the back of your mind, because we'll come back to that at the end of this proof sequence for a theorem which I've discovered. And I can teach this all the way down to at least the junior high school level. But what I'm willing to assert is definitely true. This can be taught to a high school audience, so that 100% of the audience understands this. This is one of the most interesting proof sequences I've ever run across. It's just that I didn't run across it. It ran across me. And now I'm going to share it. This has been shared in several of the lectures over the past 300. But this is the summary. We now have empty space with a reference frame. We're going to label RF, and it's the point. We do not say that this point is at the center of anything, because there is nothing. But there is this point. And that's labeled RF for reference frame. And now we don't need it. But it is there. And that's called the meta step. According to Kurt Gödel, you actually can't complete that, but it's better to go one extra step backwards to state what it is that you can't prove. I do so here. We begin with one point. that's your consciousness and just your consciousness. This is the consciousness, whatever consciousness. But it's not going to matter, because now we're saying that's nowhere. And now we've achieved something new. Nowhere. There is no reference frame. And that's our blackboard to begin the geometric construction of the universe. This is what Euclid also did, but we're going way, way behind, if I may put it that way. We are not assuming anything that Euclid assumed. We're starting over where Euclid started before he opened his mouth. So where was Euclid for this? We're not any longer concerned with Euclid. We now have achieved nowhere space. It has no shape, it has no characteristics, it has no definition except one. It's the space left behind at the meta step when you remove the point of consciousness to infinity. That's virtually tantamount to being a mechanical god for this construction, but we won't actually need to prove that. We're just saying it for the sake of completeness, that the space we begin with is the space that Euclid began with before there was a Euclid. This space came first, and now we're going to define it. As soon as I get some more soda. We're going to begin where the Greeks began, which is simultaneous when you and I began in our scholastic training in whatever culture is in the modern world now, begins this way, with a straight line. And now we have it. You picture in the blackness of this empty space, there is now a straight line. What can you say about it? It goes to two infinities. Correct? Yes. It goes to two infinities. Okay. We're now going to use a principle of Archimedes to create an Archimedean balance point in empty space. This is blank space. But not anymore, it's not, because it has two infinities. That's the first thing that we learn when we begin this way with a line. I'm going to show you in a moment that's not the only way you can begin. But we did. The human race did. This would be called in another context other than biological. This is actual evolution. This is the evolution of human science. At the geometric level, nobody has ever started other than the way you and I are going to start. But I'm going to assert right now that this is one of two ways to start. But the magic of this theorem is that it proves the other way to start. So what do we have? We have an empty space with two infinities. We now use the principle of Archimedes to declare that this line has a center. And now we have two or three things, depending on how you look at it. But before we had two infinities, which you might say was the infinity characteristic, which is one thing. And this one thing is two things. Remember that. That's going to come up dozens and dozens of times in the future. The relationship between one and two. That's a little deep at this point, but it will go that deep because this is pure magic. This is how the Greeks began, with a straight line. We know now that it has two infinities. That's not making anything up. They are related in this way. And since they are related in this way, the Archimedean principle declares that it has a center if you wish. And now we axiomatize that wish. It does have a center. But it's not the center of consciousness. It is no center at all, except in relation to the two infinities of the line. This center is linear center. It's the center of the linear anything. It's the center of the line. When the line goes to two infinities, which it does. So that's a very interesting sequence. Beginning with nothing, and even removing consciousness, we begin with a straight line, the way we know that it actually is, and it begins at two infinities, creating a center point. Now you can do one of two things, because you have something powerful now to create your space mathematically. You can see there's no mathematics here yet, but it is coming to that. This is an inverse proof sequence for what John Horton Conway proved already the other way. This is the contra. It's kind of a corollary. That by understanding the line fully, that it actually is the geometric form of our number system. The line and the linear numbers are exactly the same thing. That is extremely profound. And I'm going to show you why in the simplest manner imaginable. We now have a center and two infinities, and I said that there's now one of two things we might do. So I'm going to choose one, because of course I've been through this before, or I wouldn't even know there's a choice of what to do next now. But there is one that I chose instinctively first. And that was to erase the line and just leave the point. But I promised I would not call it a point. The only definition of what a point is or could be is the thing we already removed. Point consciousness is not in this space. It's removed. You could say artificially. We prefer to say meta-axiomatically. It precedes our axiomatic step, which is to declare our space as empty. The way we begin to say, we now have empty space. We began on the dark side of the moon, then removed the stars and the moon. So that we're pretty empty now, and then we removed what was left, which is the point, consciousness. We took it out. And that defines what is a point. We're saying so. But that's the only definition of a point. We're saying so. I've added that. It's not necessary to say any of that. But it's I don't turn anything down now. This is a discovery vector. We could be in process of furthering the discovery process. We had a line. It hit two infinities. We found the Archimedean balance. But I don't want to say point. We found the Archimedean center of the line, and that's what remains. That exists, but it only exists because of the line. Can we prove anything from that about the space in which the line is embedded? What was the shape of the space that we created? It was the shape that allows you to draw a line. Oh, that's our space then. That's right. It's the space that allows you to draw the line. It's not the line itself. That's something you drew in a space that already was there. What shape is that space? We don't know yet, but we do know this. It has a dual infinity on the line. Really? Well, that means that it's pointing in two directions. We agree. We always have agreed by saying that. That is two directions from the center. So now we have a concept of opposite direction. We can do better, and we have done better, and you know there are several ways to proceed now to show that the embedding space is spherical. It has to be for this simple reason, and you can say it this simply and leave it at that, you're done. It has a diameter. You just drew with your single straight line. It hit two ends of another shape. That is either a circle or a sphere. And that is the new way to begin geometry. You can see the advantage, or perhaps surmise the advantages to come from this. Let's go one more step. We now have determined that the straight line, which I'm just telling you is our number system, that straight line is where all of our numbers are. With a footnote, which I've gotten to many times, but I don't want to get sidetracked this time. You can probably guess what the footnote might be. What about complex numbers? We're getting there. But this is where all the other numbers are. And I've already, I won't say proved, but I've stated and tried to emphasize that the complex numbers are linear also. But they are special. The complex numbers are really an interesting innovation. But we don't want to get sidetracked. We're only interested in the fact that the numbers used, for instance, in calculus, are numbers on the line. But if you're clever, you could probably guess that that's actually why we need the calculus. To get the other numbers that are not on the line. They're on the circle or the sphere. So, to jump ahead a little here, speaking of the sphere, you might be able to think of two spherical phenomena that dominate astrophysics now and also dominate in the other direction going in the quantum world. The forces that I just highlighted on this page, right below 0 to infinity, you'll see that I'm highlighting gravity and light. Gravity is spherical, you know that. We're getting back to the antipodal theorem. We're going to complete that. But I'm giving you a taste of what this enables us to visualize now. Because we're using the same shape that we see the moon has. It's a circle and a sphere. I'm getting some soda. Beyond Antares, here we are. Alrighty then. Alright. Gravity, spherical. Light. You know that light propagates spherically, if you know anything at all about physics. It's a bit hard to visualize, especially in light of what Einstein basically proved about the photon. Well, that's getting right into the heart of the quantum mystery. We don't want to get sidetracked with that yet. What we're pointing out is that gravity and light are spherical, not linear. So we just proved something very important, that when you talk about linear space, first of all, you're talking about a dimensional system that begins at 1D for the line, 2D for the grid, and 3D for cubic space. This is the line, which is the numbers, squared space, that's that little 2 superscript, and cubic space, or cubed space, superscript 3. For the dimensionality, that's where we get squared numbers, that's where we get cube numbers and cubic formulae, which so baffled the early mathematicians, trying to figure out how to explain in their mathematical way how to do a cubic solution. That's with a superscript 3 to one of the values. Well, they wanted to generalize that. That's called algebra. Wasn't as easy as for the squared numbers. The cubic numbers are much more difficult, and it spawned such things as several amazing conundrums and, I'd say, paradoxes. But where we're at is we've just completed the antipodal theorem, which it enables us to say some things about space now that we couldn't say before. But the most important thing that we discovered is that the edge, which we had discovered from the line, that's actually the diameter of a sphere. Well, the sphere is inherently bigger than that line. And so these are the two truer levels of infinity. That the dual infinity, discovered by drawing a straight line in empty space, you hit 2 infinities, because that's the most part of the infinity you can hit. But if you hit all of the straight lines that come out spherically, it instantly fills the universe with straight lines that go out spherically and never end. That geometric production, which has several interesting, I won't say loopholes in it, but that's a little bit naive. Is it though? Was it naive to draw a straight line? What harm does it do to discover that by drawing the straight line, you've basically built a bridge to a completely bigger, obviously more complex world? The world of the circle, which is infinitely bigger than your infinite line. So the linear infinities are trivial compared with spherical infinities. Is that relationship cubic? We've tried to say so. I say that is perfectly proper for linear algebra to attempt to do that, because that's how linear algebra does everything. But is that the right way to begin with spheric space? Geometrically, is by saying it's cubed? You have to if you begin with a line and insist on extending your numbers into this new space. You're going to have to cubify the space. That's what we've done. We call it 3D. because you use 3 lines. And what we just did, we just discovered the true role of the line, which is to give us an object which we all understand. It hits 2 infinities, it rebounds and forces a center point, and from that you deduce that in one direction is a radius, and in both directions at once, which are opposite directions, it's a diameter. And from that you can draw an infinite circle, and then you spin it, and you have an infinite sphere that's rotating. And that's the ring. That's the geometric simplest entry point for energy. Instead of beginning with a line, you begin with the integral line in 2D space, which is a circle that bridges both domains. The circle is curved, so it's a derivative of the sphere, but we made it from the diameter. That means it's linearized. It's the linearized sphere. That's what the circle is. So it's magic, because it captures linearity on the diameter. And that's where you put the irrational numbers. That's where they already are. That's already been done by nature, and that was proved absolutely, finally, by John Horton Conway, that the straight line is infinitely dense with numbers. This is the simplest way to say what he basically proved Cantor, but to finalize Cantor, to stop the madness. He basically closed a loop, and I noticed that. That implies a specific geometry, that the straight line is embedded space. What I surmised is that the straight line that you and I just drew to prove that that's actually the diameter of a sphere. When you draw a straight line to 2 infinities, you've declared the existence of a sphere. But it has an extraordinary characteristic. It just keeps going. We have a word for that makes that rational. If you freak out, you could say it just keeps going. Well, that gives you vertigo. What you should say, and we do say, it's unbounded. And that's a sterile characteristic. It's unbounded. Whoop-de-doo. But there's one thing that you have to recognize. Since it's unbounded, it's not a space. We've learned how to use linear space because of the numbers on the line. That's why numbers are so powerful. They do represent a spatial perception. It's linear, but you see, the linear system is the derived. And now invert that. Take the number system that we have. If I'm saying that that's the derivative geometry of sphericity, that the line is the derivative, I'll say of the circle for now because it's simpler. But when you draw a line, you make the circle and the sphere. The circle is embedded in spherical space, and those are the 2 dimensions of circular spherical space. It has 2 dimensions. The sphere is the complete dimension as far as we're saying so far, but the flattened sphere, just like the moon, remember? Let's make sure we get a good look at that. There is the moon. That is a circle. It's also a sphere. Which one is it? Is it both? Yes, it is. And I'll tell you why. Because we're hardwired to see it as a circle. That's been, I believe that has been proved by neurophysiology. Of course, they've addressed this issue very carefully as they can. As you might imagine, that's very difficult to decide. Do we see 2D, or as we would say mathematically, do we see 3D. What we do see is both flat and the circle. We recognize both and what they mean. And so we can learn, as we learn fairly, I think, automatically, that even though we're seeing a circle, that's actually a sphere. But boy, do they look exactly the same? That has a geometric significance of very strong order of significance. Because in linear space, when you make a grid, it turns out to be magical because of orthogonality. But if you begin the way we just began, you can erase the line and replace it with the integral line, which would be a force. It would be expressed as a force either going into the center, that would be gravity, and there that has a name, a class name, a type name actually. It's centripetal force. There's only one other, centrifugal. That's going out from the center of the geometry. The geometry can use a force expression to define its axis. The universe has done so. It accepts that geometry. That is its geometry. It's definitely not linear. It's not, you can linearize it, you think. But if you start this way, you can see it. You can understand it. It's definitely spherical. Well, that means that it's definitely not linear. Because the spherical space has hierarchical precedence. We can see the sphere in a different way that's obviously more expansive than anything we can see on a straight line. But straight line measurement is so natural to us that using linear algebra, at first it seemed like it's just automatic and innate, but eventually in trying to analyze curvature, we came up with sine, cosine, the calculus, and the complex numbers. All absolutely necessary in linear space. We just showed you don't need that. What we do know already is what I said is only half true. We actually do need that, and I'll tell you why. Only the linear numbers are computable. Only the linear numbers are computable. So that forces the straight line system at the machine level. When you finally go to program it, which is a marvelous thing to be able to do, by the way, but in order to do that, you have to comply with machine logic. Well, you can do so and build a working linear algebra system on a computer. Obviously, we've mastered it. How interesting now to find out that that number system, which is so useful, is the derivative number system of a parent. That is, hierarchically, it's the derived algebra of a different geometry. That the line-based system of the universe that we've used for about 2,000 years is all based on linear numbers, all based on trigonometry. We've never conquered the circle. We've never understood circular space. We're having the devil of a time with spherical space now because we're not using that geometry. There are, of course, very powerful reasons why we continue to use the linear algebra approach. We do get a lot of benefits, but is it the ultimately right way? I think you can see for yourself. I won't say one way or the other. I'm merely presenting the geometrical truth that you would have to decide. I have decided, and I can teach you more if you would like to listen. But from now on, I am going to have to remind you that this is something that right now only I know this. So we're coming up on 2 hours. And I told a lot of stories. Let's see if we can breeze through this, really. Let's see if we can breeze through this. So at the end of the antipodal theorem, we're now ready for a blockbuster, and we'll wrap up on this, because now that we have the antipodal theorem, which proves that the universe starts in spheric space, and we've learned how to use a derivative system. I'm just going to mention this has a direct bearing on the meaning of the calculus, which is just going to be good news of great tidings of glad joy worldwide as we finally burst the cocoon of this miserable, horrifying system called the calculus. Why not just integrate it? Why not just figure out what it does and invent a number system where it's just done for you? Because we wanted versatility, for one thing, to get any curve, not just the circle or sphere. However, that is what cosmology deals with, is the circle and the sphere and nothing else. Unless you're studying galactic jet dynamics, you have nothing to do with straight line distance measurement. Oh, you have to know how to do that to get cosmic distances using the cosmic distance ladder. Well, the further out you get, the spookier it gets, it turns out. But we've done a good job. We have a pretty good handle on the structure of the universe, as I hope I was able to share yesterday. It is indeed 6 cosmic units. Never told you the 7th one, but I am going to tell it to you now. You know, it's stellai, the star, nebulae, the galaxies, cumuli, the spherical clusters of galaxies, the strati, which are spherical constructions of those spheres, but they're all connected with strands, making a web. And so that combines to make 2 structures. First of all, the nexal points in a polyhedral system. These are called the vertices of polyhedra. Yes, but it is true. That is the verdict of science. I'm just telling you what science has discovered, although people don't ordinarily put it in the geometric way. But it is a web of spheres, of galaxies of stars. Now, what we would like to do now is match a geometry to the universe if we can, but first of all, we'd have to ask the universe what it wants, and it tells all of us right away, first thing you're going to need to do is figure out infinity at the edge. What is that? We've decided it has a name. We call it either the edge or the boundary. But what we're saying is we have an incomplete space. It's not a geometric space because it's an unbounded space. And now we can employ the antipodal theorem that builds, we just did the antipodal theorem. We can now use that to establish a second theorem that begins in spherical space. It's empty spherical space, but we do know it has a center, but it's not a point. We don't call it that. We just say it has a center. The closest analogy, it would jump to mind, would be a point. It's going to end up, I'm just going to give you something that can be shown later. That actually is a point, but it's the only point. If you're going to have a point, you can't have more than one. You can only have one point. Jǒsip bôʃkoʋit proved that 250 years ago. So that is established fact. It also makes perfect sense. And I am not sure anybody would even argue with that. I don't know why. But it is interesting to notice that we were very cautious, and I now know to do this, but it all fits. You want to be careful when you say the word point. I can already, and I think you can enumerate 3 kinds of point that have nothing to do with each other really, except one thing they all have in common. They're the center of something. We found that on the line, but that is the linear Archimedean. We are no longer considering linear Archimedean, although it's always there if you want to use the derivative system. One of those lines has all the numbers, but the spherical line is all the lines. Then the direction, instead of being this way or that way, now the direction on the spheric line, which is the fully rotated line, so it describes the spheric space from the point of view of rotating the line anywhere. That fills the space with line. We would say lines, but literally it's an infinity of lines. But we had an infinity of one line, it hit 2 infinities. Well, what infinity does that line hit? It hits 1 infinity. It's the integral of linear infinity. That's actually the most perfect definition of the calculus possible. To a threshold, a new threshold. We actually use the calculus. I'll just say the differential form is to get linear numbers out of circular numbers. It's that simple. That's what sine cosine does. And those are calculus created functions. Sine and cosine are calculus functions. They're simplified for 2D space, but basically you get 2 numbers out of 1 number that are related. But you only want, you want them to be separate, but they do have to be related. Why? Because x and y are related in flat space. It's not a one component number system. A straight line has a 1 component number system. But if you add an orthogonal line, you have a 2 component number system. If you add a third line to get depth orthogonality, which is kind of magical, you have a 3D system. It's a 3 component number, x, y, and z. It's way more complicated when you go to 4, as Albert led us to do. But that's not what we discovered to be the best way to begin. The best way to begin is, first of all, to have gone through that, because there's no way to know there's a better way until you have a way that's so good that it answers the description of what we do have with linear algebra. Absolutely magical for production technique. You can get anything you want on Earth with calculus. So yes, it's good. It's the only good game in town. The problem is not with the calculus. It's a wonderful tool. It's the assumptions you have to make to use it, because it does throw out a lot of waste number. And there's no real trash can to drag to in the cosmos. But calculus throws out a lot of shredded material. And in geometry, we just can't allow that. Your calculus cannot enter here. We'll tell you what your calculus is going to be capable of. But to do that, to ride that high horse, you have to begin where we just began. But we don't have a number system for spherical space. Let's see what we could do next now that we have spherical space. What do we have? We have one edge and we have one center. And that's it. Although there's notes. It's the integral of linear space. Now what we want to decide now, are we going to treat this as spherical space? I don't see why we wouldn't, since it is how we see. I told you before, we do see in 2D. Here's the secret. The physiologists passed on to us, we have two modes of vision, and we use both. One of them is 2D, which is actually spherical flat space, and the other mode is with depth. We can compute depth very rapidly if we have enough clues. But we still always have 2D vision, and that's why cinema fools us. That if a train is coming towards you on the screen, you might flinch. And if you're like my dad and I, when you see someone like Spider-Man or anyone jump off the top of a skyscraper, my dad and I curl up. It's automatic. The body just, because it looks so real. Got to be careful with that too. It's very convincing. Anyway, so much for linearization of space. It's very good if you began that way and you got used to it. We certainly did. Linear algebra is magic, but it's also very difficult. It's extremely difficult to do calculus for the purpose for which it is so often needed, which is to build things to specification. It's marvelous at that, because you can throw out stuff in the machine shop. In the universe, it's a little different throwing out stuff. You can pretend all you want, but when you're looking at a Bohr atom and it's spherical, is it any wonder our numbers might be conceived of as having broken in some way just because they're so small? That diameter of the sphere is always forever to infinity smaller than the sphere itself. That is the quantum limit. And so we can now execute the bootstrap theorem by taking the center and the edge of the unbounded space, which is useless space, and do the first thing that we would have to do to make it useful. It's kind of open-ended what you might do. No one's ever tried what I'm about to do, but I think you can follow along. We're going to say the edge is a thing, and it has a number. And we're not going to say anything else. It just has a number. We'll give it a name for convenience. We'll call it infinity. So the edge has a name. Now for the center. That's going to have a name. For a number. And so now, according to our axiomatic approach, we have two numbers. One at the edge and one at the center. What might we say next? These numbers have no definition except what we just said they are. The right question a geometer would ask: do they have a relationship? Does the number at the center have a relationship with the number at the edge? You could say whatever you come up with, just take a look at the straight line again and see if we can learn something from it. OMG, can we ever? The Archimedean center of the straight line is a number, but only on the straight line. And you know what it is, but we're not going to name it. We're just going to say it's the Archimedean of linear space. It's the Archimedean of the line, and it is a number. We said so. It took a long time before we did say so, but now we're sure that's what we want to do. That center of the line is a number. What about its infinity? That is the linear number for infinity. What we're looking for is the spherical number for infinity. Let's look at the straight line again. It has one infinity in two parts, and at the Archimedean is another number. What is the relationship? This is a tough question. See if you can guess. It has to do with an operator. You have plus infinity. You have minus infinity. You have a center whose number we have not named. What happens when you put plus infinity and minus infinity together? They add to 0. And that's the geometric definition of the line. We transfer that to spherical space directly. No alteration. We had two directions, positive and negative. What do we have in spherical space? Two directions. From the center or from the edge. You could say that another way. To the edge or to the center. Those are the two directions. They are spherically opposite directions. They're spherically opposite on the operator for the space. For the line that was add, because the two infinities add to 0. In spherical space, we're going to say that the number at the edge is infinity over 1. And the number for the center of this space, just like for the line, but not for the line, for the sphere, but it's exactly the same process. The number at the center is no longer 0. And the operator is no longer add. It's the multiplicative operator that cancels the two infinities on multiplication to 1. On the line, the two infinities cancel to 0. In the sphere, the multiplicative identity cancels to 1. And that's the 1 in universe. That is the 1 in universe. The center is a 1 because it's spherical. That is, to me, a watertight proof that you now have a two-component number system of reciprocal numbers that are Archimedean on the multiplicative identity, completely analogous to the straight line, except it's the calculus integral of additive space, which means you just solved for the calculus using object-oriented programming. We now have a sphere that is parameterized on two reciprocal numbers. They're not plus and minus infinity. They're the edge and the center, which we now say, we declare, is imaginary. It's imaginary. To the proportion that it's imaginary at the edge, we now can state it rationally. It is inverse proportional infinity to the center of your system. And that's the 1 that's at the center of the system. We know from the diameter of that 1 that we now have found the bridge between linear space and spherical space mathematically. It's the definition of the calculus. And so this two-component reciprocal rational number system for spherical space can now be used rationally. It's ready to be used. What does it mean? That'll be in the next lecture. This is 2 hours and 20 minutes. That's too much. Although I have watched many interviews that went over 2 hours. Thank you for your patience and for tuning in. Don't forget, this is where we began, but we're also trying to get out and discover what the quasars are. And I still haven't told you the 7th cosmic unit. I just gave you half of it, though. The 7th cosmic unit is a purely geometrical product. But if you would, it does solve the 4D dilemma. And 4D is part of the paradox. Whenever you go to solve a paradox, like, I'm just used to this, so I can pass this along, look for 2. They're paired. And so the paradoxes that we've been facing, both in quantum mechanics and in cosmology, ultimately come from this. That we're not yet using the integral number system. We're going to need the metric, and it has to do with time and space. Stay tuned, we'll be back with more. It's 100 degrees here. You saw I loaded up on soda. There's more to come. Stay tuned, we'll be back. This is Anagalactic with the Secrets of the Universe. We're reconstructing geometry so that we can use a new number system that addresses what physics has discovered in the 20th century. The entire universe runs on spherical geometry. So we do need its number system, which I discovered in 2022. It has been proved. You just heard part of the proof. But we still haven't discussed the metric. That will be the space-time metric. We'll be right back. Keep looking up.